Okay, good afternoon. This is Saturday, the 22nd, I believe.
23rd.
23rd, all right. 23rd of September. Yes, it's been a long month, yes. We're here, this is Houston. My name is Brian Lance. I'm going to be giving a short introduction, and then we'll be turning it over to Joel DeJean, who will take up the subject of space weather and what we're learning about it and its applications. And I want to start with just, as I said, a few remarks. First of all, we'll begin circulating at some point this week a dossier which will go out nationally on Robert Mueller, the special prosecutor who is targeting the presidency, the institution of the presidency, as well as the individual Donald Trump. And this is extremely important. I'm not going to spend time going through the details here. I think most people have some sense of this already, that this witch hunt against President Trump and really against the American people has got to be shut down. The point I want to make right now is that with what we've seen of late with hurricanes Harvey, Irma, Maria, the earthquakes in Mexico, and the rest, which what Joel is going to have to present will bear upon, we have to have a country, a nation, a sovereign nation that can function, that can rise to meet not only the immediate threat, but can build its way out of this profound crisis. Helga LaRouche and Lyndon LaRouche emphasized just in the last 24 hours that we can't take our eyes off the financial crisis that's building up. Just think about it. If we now have a blowout of the international financial system and its physical consequences, physical economic consequences, on top of what the southern states, including Texas and Florida, Puerto Rico, Caribbean nations, and so on are suffering already. If we have this on top of it, and of course Mexico, which would also be direly affected by a global financial crash, this is just over the top. So the time is over for small thinking, petty thinking, bean counting. I mean, that's what we've had in terms of a decision-making process on the local level. If you look at the Harris County Flood Control District, not to blame them per se, they're engineers, they're tasked, and they do the job they're assigned. But at local government level and so forth, we've had a kind of bean counting, limited resources, what can we get by with? And of course, now we've ended up paying, an order of magnitude or 2 orders of magnitude more as a consequence just of Harvey. You can just take that point and expand it and think about Puerto Rico. And think about where Mexico would be today without NAFTA. Mexico was a functioning country. It was a country that had initiated a pathway in the 1980s for industrialization, was working with Japan, was working with Mr. LaRouche's economist, and where would it be today if that pathway had been allowed to continue, if they had been able to build themselves out, and what their capacities would be today for dealing with the earthquakes they've suffered in the last few days. Now, in terms of the financial crisis, there's the $2 quadrillion bubble out there of the global derivatives market, and anyone can look that up. And whether you want to talk about it as 1 quadrillion or 2 quadrillion, it's a lot of zeros, and it's a lot of 0, 0. It's the largest Ponzi scheme in the history of mankind, and it's set to blow. Now, even Deutsche Bank, which itself can be considered among the walking dead in terms of the global financial community, and has been for a few years at least, Deutsche Bank's analysts have put out a report just this week, about 4 days ago, spelling out that there's at least 11 different triggers on this financial crisis, this financial collapse, which they say will happen. They don't say collapse, they say financial crisis comparable to 2007, 2008. So they say this, another one of these is going to happen, and they rattle off a set of different triggers, some more important than others and so on. But just to emphasize a couple of them, quantitative easing, the unwinding of quantitative easing, that financial term that came into existence in 2007, 2008, that central banks have bought up something on the order of $14 trillion worth of toxic financial paper and government debt to set loose cash, to keep the banks afloat, the financial system afloat, to ensure the liquidity that could shore up that quadrillion-dollar Ponzi scheme. Well, now the Fed has announced, Yellen has announced, and other central bankers are leaning in the same direction, that they're going to begin selling that financial paper back into the market that they bought it out of. Well, if they start selling that financial paper, they're going to have to offer something enticing to be able to sell it. So they're going to have to raise interest rates on that financial. They're going to have to offer, they're going to be selling a bond. Well, I'll give you 6% or 7% as opposed to 4%. And so, well, if they start raising interest rates on what they're offering, what's going to happen to other financial paper out there? What is going to have to be, what's the interest rate going to be on that financial paper to keep it, turning over in the markets? And so you see very rapidly, suddenly you can have a massive train wreck, a freeze up, to use another analogy, of the whole financial system as it just seizes up in the midst of a sudden spike in interest rates. And of course, this comes on the top of another point that they make, which again is not new. The collapse of asset values is another trigger. Well, what does that mean? Well, the amount of corporate debt in the United States has doubled since 2008. It's gone from about $7 trillion to $14 trillion. Well, that's borrowing by corporations. Well, if interest rates start rising, then the interest rates on the money they borrowed starts rising. So suddenly, even the IMF says 10, 20% of that corporate debt is suddenly going to be, just bankrupt. Those companies are going to be bankrupt. They're going to be, unable to service that debt. And that paper will be worthless, and those companies could very rapidly follow suit. So that's another trigger on this whole thing. And then on the other hand, you could just have the government starting to print money because, look at it. We've got crises, we've got bills to pay, and if those don't go away, if they're not solved, to put it in a better way, if those crises aren't solved by national banking policies of national credit to put the real physical economy back into motion and grow our way out of this crisis, then how is the government otherwise, President Trump or whoever, how are they going to manage to pay the bills on this growing crisis, global crisis? So if they start printing money, not only here, but in Europe and so forth, well then hyperinflation, rising interest, and you can see how all these things come back upon themselves. These are not really different triggers, if you will, they're all related. So I just want to come back to this point about bean counting, what I'm loosely calling bean counting here, and then I'll wrap this at this point. Economics, fundamental physical economics, is not about what something, the value of something, at the point of sale. The value of something, we don't actually have a Robinson Crusoe economy, a so-called von Mises economy, in which the total is just the sum of all the individual greedy decisions that everybody makes everywhere, all over the world, and the total of what we had is the sum of that. And nor is that the utopia that we should aim for, as if all of those individual greedy decisions were going to amount to actually their general welfare being actually approximated. Quite the opposite. What we've seen, what we've had unfolding over the last 2 generations is an increasingly Hobbesian world, a kind of hedonistic calculus of individual decision making. In other words, localized decision making, not just individuals, but businesses, companies, county governments, local governments, everyone trying to fix their problems at the local level. You know, and it may be in community meetings, or it may be behind the back, you know, in the back room. It really doesn't matter. The problem is with it being local. You know, this adage, the old adage, all politics is local. You know, this is completely bankrupt, always was. Well, now we've got to go to a higher level here. We have to go to the nation state again, and we have to go to the cooperation among nation states. That went to the best side of what Trump said at the UN speech, which most people didn't hear. The worst of it, in terms of the threats of overthrowing governments and so forth, people did hear. That's the battle. That's the battle going on right now. Which way? 2 systems before the world. Do we go to the nation state and return to the concept of the sovereignty of nation states and the development of the creative powers of the individual as being our most fundamental resource, or do we simply descend further into barbarism? That's true in terms of economics and solving this crisis, or whether we will solve this crisis. But it also goes to this question of science, of scientific method. You know, the whole is always greater than the sum of the parts. The principles out there yet to be discovered are always more than we already know in terms of physical science. Obviously, many people are grappling with what are the causes behind this sudden, apparent change, at least, in climate, in weather, in storms, earthquakes. Not that we can answer all of that right now, but the point is, we've got to get ourselves together here and say, okay, we have to go in the direction of making these discoveries. And those discoveries aren't going to be made sitting on an island with Robinson Crusoe. So with that, let me just turn this over to Joel DeJean, scientist, engineer, and he's going to take us to these questions of galactic weather, but also some of the implications of what that can be for a better future for mankind. Joel? Got your way there.
Make sure I don't topple the world over.
Yeah.
Okay. So I wanted to start with a stroll to the neighborhood, the inner solar system. And I think it was Confucius who said that a journey of 1,000 light years starts with 1 step. So let's start, since we're on the Earth, let's start here on Earth. Now, as we sit here in this room in Houston on the Earth, it seems like we're standing still. We're pretty firm ground. But it turns out that as we sit here, we are actually traveling at 1,000 miles an hour. Because the Earth being approximately 24,000 miles in circumference. And by the way, the Greeks, 200 years before Christ, actually measured the circumference of the Earth to a high degree of accuracy. Now, so we're rotating 1,000 miles an hour. Now, the Earth and its satellite, the moon, we are rotating around the sun at 67,000 miles an hour. And the whole solar system is rotating around the galaxy at 500,000 miles an hour. So I wanted to go through a little bit of the dimensions we're dealing with. Like I said, the circumference of the Earth is 24,000 miles. The diameter is 8,000 miles. Now, our moon, which I forgot my softball, so this is not my dessert. This is represents the moon. The moon is 2,000 miles in diameter. Now, going to the sun, and Mike, if you put up first.
So we get the lights.
Fine. Is it up?
Yeah, it's up.
Okay, so the sun is it here.
Yeah.
Yep.
Yeah. That's it. You should tell me where it is. Now the sun is 864,000 miles in diameter. So it's over 100 times the diameter of the Earth. You could actually fit 1 million Earths in the volume of the sun. And the sun weighs, the mass of the sun is about 330,000 times the mass of the Earth.
Say that again.
The sun is 330,000 Earth masses. So most of the solar system, 99% of the mass of the solar system is in the sun. The sun is a plasma, so that it consists of mostly hydrogen and helium, where the electrons are freed from the nucleus. So you have a swirling mass of electrons and nuclei, positive nuclei and negative electrons. Now, most of the visible mass in the universe is plasma. Plasma being the fourth state of matter. You have a solid, you have liquid, you have gas, like the atmosphere, and you have plasma. Now, the biggest planet, Jupiter, is 80,000 miles in diameter. So if you think of the Earth and you go 10 times the diameter, you get Jupiter, and you get another 10 times the diameter, you get the sun. Now, what drives the sun is fusion, nuclear fusion. Now, as we go from the surface to the center of the sun, now think of it, it's 400,000 miles to the center. As you get closer to the center, the pressure, the heat increases to the point that fusion occurs at the very center. Every second, tons of hydrogen is converted to helium. And the heat begins to go towards the surface. Now, because of the density of the sun, it's estimated that by the time you get fusion, it takes about 1 million years for that energy to reach the surface of the sun. Now, the surface of the sun is 10,000 degrees Fahrenheit. And you may remember during the George W. Bush administration that he had proposed a manned mission to the sun.
Yeah.
And Condoleezza Rice reminded him that, George, the sun is 10,000 degrees Fahrenheit. The spaceship will vaporized before it lands, and there's no solid surface. And George said, well, that's right, we'll go at night.
Oh.
But Cheney, who was the brains of the outfit, said, oh, that's no problem. We'll just go during a total solar eclipse. Now, I wanted to get to the solar eclipse. Now, this Monday, it'll be 5 weeks or so since the solar eclipse. It seems a lot longer than that, because we've had a lot happen then. But just to go through the orbital mechanics of the solar eclipse. Now, you have the moon orbiting the Earth spinning at 1,000 miles an hour. The moon, which is about 250,000 miles away from the Earth, is rotating the Earth at about 2,000 miles an hour. So think of this solar eclipse we just had as a real celestial dance. So you have the Earth moving around the sun, and I'm sure you all noticed yesterday that the sun crossed the equator at about 3 o'clock, 3:02 yesterday.
3:02, oh yeah.
Now, because the Earth is tilted 23 degrees, 23.5 degrees, as it goes around the sun, if the northern hemisphere is tilted towards the sun, that's the summer. If it's equidistant, that's the beginning of fall. And if it's tilted away from the sun, that's the winter. And the opposite in the southern hemisphere. So on August 21st, you have the moon orbiting the Earth. Now, if the sun is over here, how is it that a 2,000-mile wide moon can block the sun?
Distance of the sun. Exactly.
Now, it turns out, and to paraphrase Kraft, Erica, if God had meant for man to understand the sun, he would have given us a moon. Now, it turns out that the moon is 400 times smaller in diameter than the sun. But the sun is 400 times greater distance from the Earth than the moon is.
Wow.
So that when you look at the sky, the moon takes up about the same
arc length.
Yeah, arc length, about 1 degree as the sun.
Yeah.
Now, remember what they said before the solar eclipse. I should have told you this before. You should wear your eye protection before you go outside. So I'm sure you still have your eyewear. You can put that on. But just to go through the mechanics involved. So you have the Earth orbiting the sun. You have the Earth spinning on its axis. Now, on August 21st, the moon came around, and if the moon was exactly lined up between the sun and the Earth in the same plane, you would have an eclipse every month. But because it's offset by 5 degrees, you only have an eclipse somewhere on Earth every 18 months or so. So as the sun came up at around 10 o'clock in the morning in Oregon, I can't tell which was Oregon, but pretend this is Oregon. So you have the moon coming up and blocking the sun. Now, the far side of the moon at that point is getting all of the sun So you can't really call it the dark side. It's just the far side that we don't see. So as the Earth is spinning, the moon is catching up with it and blocks the sun. And we knew to the exact second when the shadow would reach various cities along the lake. And it went from Oregon all the way to South Carolina in a few hours. And they knew exactly what would happen. Now, we know a lot about the sun. We know the fusion process. We know how much hydrogen is converted. But there's a real paradox that we've known for the last 150 years or so, is that while the heat at the center dissipates as it reaches the surface of the sun, like I said, it's 10,000 degrees at the surface. There is something called the coronosphere, which is millions of degrees. And the paradox is, how is it that heat increases as you go away from the heat source? So that's a real paradox. Now, they were using last month the solar eclipse to look at the corona. And if you can put up the corona, or the is that the eclipse?
Yeah.
Yes, sir.
So beautiful.
Okay. Now, this is not the one from last month, right? This is from
99, I think.
99, but it's the same effect. Now, the thin atmosphere of the sun, where you have millions of degrees, is so faint that during a regular day, the sun is so bright that you can't really see what's going on in the corona. So what they use a solar eclipse for is not just to go out there and see the sun become dark, but they take advantage of the eclipse to study the corona. And by the way, you all know what the best beer to have during a solar eclipse. This is not a commercial, but it's a corona.
No, Corona.
Now, so you have the eclipse. Now, the best way to observe the eclipse is not on Earth. NASA actually had 2 jet aircraft fly along the path of the total eclipse.
Your head is blocking the eclipse.
Am I eclipsing the sun? So they were able to, instead of just 2 minutes, where most cities, if you got 2 minutes of totality, that was good. But these jets were about 50 miles apart, and they had special cameras, infrared, ultraviolet, to look at the corona. And they were able to observe it for about seven minutes. So during this totality, they were able to see what's going on in the corona, where during regular daylight, looking at the corona would be the equivalent of trying to examine a light fly, in front of a headlight. Then you lose a signal. But during the totality, you can see the corona. Now, because the moon is in an elliptical orbit, sometimes you have not a total eclipse, but what they call an annular eclipse. Because it's further out from the Earth, it doesn't block out the whole sun, so you get something called like a ring, annular eclipse. But during the total eclipse, you can actually examine what's going on in the corona. Now, if you go to the next one, the flare.
There we go.
Now, I forgot to point out, the sun has regular sunspots. Were you able to see the dark spots in the previous one?
On the sun?
Yeah.
Yeah,
The first picture.
not the eclipse. Now, because the sun is a plasma, now the sun rotates about its axis once every 28 days. And because it's a plasma, it's not a solid like the Earth. The plasma, certain sections of the plasma rotate at different speeds. So it produces magnetic fields, very complex magnetic fields. And as these fields twist and wind, when it bubbles up to the surface, certain points where there's a large magnetic field looks darker because it's actually cooler than the surrounding photosphere, the surrounding surface of the sun. Now, during just regular sun cycles, you have these sunspots generate what's known as solar flares. Now, can you see the arch
Yeah.
of the flare? Now, just to give you an example of the amount of energy released. Now, some of you might have heard of the Harvey program,
Yeah.
the High Frequency Active Auroral Research Program. And some people think that that's what causes earthquakes and what causes hurricanes. But just to give you an energy comparison, 1 ton of TNT is equivalent to 4.1 billion gigawatts, or the release of 4.1 joules every second. The HARP program, which was a research program in Alaska, was examining the ionosphere, and it was injecting about 1 billion watts into the ionosphere for a few seconds. X flare, and these flares have different categories. Mike, you remember which one this is? Is this an X flare? Or?
Well, no, this is probably just your basic sunspot, relatively low level. It's not like a coronal mass ejection.
Okay. So you have different categories of flares, A, B, M, and X. An X flare will release the equivalent of 10 to the 27 joules. Now,
Wow.
to give you an example, the bomb that was exploded in North Korea just a few weeks ago had a yield of about 100 kilotons. Say a bigger hydrogen bomb would have a yield of 1 megaton. One solar flare will release the energy equivalent of 1,000,000 trillion tons of TNT.
Joel, can you say again what causes the flare?
What you have is because the sun is a spinning plasma. You have these magnetic, so you have these charged particles rotating. And anytime you have moving charged particles, you produce a magnetic field. And because they're not moving uniformly, you have magnetic fields that begin to twist. Think of a rubber band that is twisted. So you have these magnetic fields begin to twist around each other. And as the magnetic fields get more and more wound up, they reach a point where they break and they release the energy. And if you have an X flare, you not only release the energy, but you release tons of charged particles out into the solar system. And that's what's called a coronal mass ejection. So the flares are a result of the magnetic field lines breaking and recombining and in interaction with the charged particles in the sun. Now, the interesting thing about the coronosphere is that there's a theory now that what causes the heating of the coronosphere, again, instead of being 10,000 degrees, it's millions of degrees. They think that there are millions of what they call now nanoflares, smaller than these large X or MAB flares on the surface that loop up to heat the coronasphere. And in this last solar eclipse, they were able to actually photograph some of these nanoflares. Now, if we are to master fusion, you think that the easiest way would be to repeat what the sun does. The only problem is we can't really recreate the gravity of the sun on Earth. Because you're talking about 300,000 times more mass than the Earth itself. But if we were to understand how these nanoflares are combining and reconnecting these magnetic fields, and this is a lot of the research that's being done now in Princeton, which we visited a couple months ago, that they're using rotating magnetic fields, and they're using the reversal of magnetic fields to heat a plasma. And the problem they're having is to get enough heat into the plasma where you could have fusion occur. So if we were to study these nanoflares and recreate in the laboratory these nanoflares, these smaller flares, then we'd be a lot closer to achieving a controlled thermonuclear fusion here on Earth. Now, the other phenomenon we had last month, as you all know, is the hurricanes. Now, contrary to the opinion of a lot of so-called scientists, including the great climate scientist I heard the other day, Stevie Wonder.
And Jennifer
Yes.
Lawrence. Don't forget Jennifer Lawrence.
And Beyonce was his assistant, I think.
Yeah.
But I heard him say that after the hurricane, that you'd have to be blind not to recognize climate change.
Oh, please.
But what does cause climate? Well, it probably doesn't take a genius to figure out that the sun might have something to do with our climate. And if we look at the history of sunspots, and sunspots go in 11-year cycles, increase, decrease, and there are other cycles, longer term cycles. And we've observed that if you have a decrease in sunspot activity, you have a decrease in the Earth's temperature over long periods of time. Now, that is completely ignored by these climate scientists. Now, over the last...
Sorry, Joel, did you say a decrease and a decrease? I mean, I just wasn't sure.
Right, a decrease in sunspot activity will result in a decrease in Earth's temperature.
And you said over a long period of time, meaning the effect of the decrease lasts a long time, or over long observation periods we've identified that?
To give you an example, there's something called the Maunder minimum, where over a 50-year period, we've been observing sunspot activity for about 400 years, since the 1600s. And they recorded how many sunspots they see on the sun's surface during that period. And during that 50-year period of low sunspot activity, you had people ice skating on the River Thames in London. And you had a mini ice age in Europe. So what is thought to happen is that it's not just the sun controlling Earth's climate, because the sun and the solar system is embedded inside the galaxy. And this is some of what Ben Denniston went through last week, and he's gone through this previously, is that the sun not only provides us heat, but it acts as a regulator to the cosmic ray flux that comes into the solar system constantly. Now, it's thought that the cosmic rays coming into the Earth's atmosphere will ionize molecules in the atmosphere. And it's thought that these ionized molecules provide the kernel for water vapor, water to condense on these ions. And that's what causes clouds, cloud cover. And it's been observed that even shorter periods, where if you have a large flare, X flare, and over the next 3 or 4 days, the corona ejection will reach Earth if it's lined up properly, that flare will cause a reduction in the cosmic ray flux. And what was observed during Hurricane Katrina is that there was a large X flare during the time where Katrina was crossing Florida, coming into the Gulf of Mexico. And what people like Sergei Pulanets, who's a Russian scientist, he's spoken at some of our conferences, and we've talked to him since the Fukushima earthquake. It's thought that if you have an increase in solar ejections, that will decrease the amount of cosmic ray flux coming into the upper atmosphere. And because hurricanes depend on the difference in temperature between the seawater and the upper atmosphere, the irony that if you reduce the temperature difference, you can reduce the strength of the hurricane. But if you reduce the cosmic ray flux, thereby cooling the upper atmosphere and increasing the temperature difference, it can strengthen the hurricane. And that's what was thought that happened with the Katrina. But if you can go to the slide with the hurricane.
Okay.
You recognize this one?
Oh.
This is our nemesis,
Oh, this is Harvey?
Harvey.
Okay.
Now, where do hurricanes come from? Since it's not hard.
It's not hard.
It's thought that from the Sahara, you get high temperature winds spin off of the Sahara, come onto the Atlantic. Now, because the Earth is spinning and warm air rises, as a spinning air mass heats up, the warm air will rise. And because of the spin of the Earth, something called the Coriolis effect will induce the spin in the northern hemisphere to be a counterclockwise spin. In the southern hemisphere, it's a clockwise spin. And as the spinning continues, if it's going over warm water, and you hear this all the time, because of global warming, we have warmer water, and warmer water means stronger storms. But what they fail to account for is what's going on with the cosmic ray flux. So if you look at a storm like Harvey, you have this spinning air mass, and can you see the eye of the storm?
Yeah.
Oh, yeah.
So the strongest winds are in what's called the eye wall. And it's getting the heat from the Gulf of Mexico. And the warm air is rising and sucking up the water vapor and continuing to spin. And as it comes over land, it dumps all that water, as we saw last month. Now, what Ben went through last week and what some experiments in Mexico have shown is that if you have an ionization field in front of an oncoming hurricane, it was demonstrated during various hurricanes that if you have an increased ionization field before the storm hits the land, you'll reduce the strength of the hurricane as it comes on board. Now, one thing that has not been tested is that you've all probably seen these hurricane hunter planes that fly,
Yeah.
propeller planes that fly into the eye and measure the pressure, the speed of the eye wall. Because a lot of these you can't see from the satellites. You can see the overall shape, but you can't tell the exact pressure, the exact speed. You actually have to go in there.
Are they piloted or are they?
Pilot, yes.
Yeah.
Yeah.
Boy.
Because once you get into the wall, the eye is supposed to be calm,
Mm.
and you have the eye wall spinning around.
Mhm.
Now, if we were to equip an aircraft with ionization wires and actually fly this into the eye of an oncoming hurricane, we would be able to begin ionizing and thereby reducing the temperature difference between the top of the hurricane and the seawater, and thereby reduce the strength of that hurricane. Now, that's something that we should be testing. Now, you obviously don't want to test it on a hurricane that's about to hit land, because you might have miscalculated somewhere.
Did they do that though with Hurricane DeJean?
No, I haven't gotten back with Ben on this, but as far as I know, Hurricane DeJean was weakened with stationary ionization stations. They haven't tested it with an aircraft yet.
Where was that?
Hurricane DeJean, I think, came from the Caribbean and hit the Yucatan back in '98 or something like that. And they happen to have an ionization setup in that area. And they tested it out, and they actually reduced the strength
Wow.
of the hurricane. It was in category 5, and it was reduced to category 1.
Wow.
Now, I don't know how much of that was due to ionization and how much was just from it crossing the land.
Wow.
But I think Ben is going to be publishing some more details on that in the coming weeks. But this is the type of experimentation we could be doing to not only observe the hurricane, but using the principles of the galaxy to actually control the power of the hurricane, similar to what the sun does, but this time using our ability to ionize above a hurricane to act like what's called a four-bush effect. And four-bush is not anything to do with Bush. That's the guy's name, is four-bush. And he discovered that if you have this increased input from the sun in the form of the solar wind, it will reduce the cosmic ray flux and it will increase the temperature difference and increase the strength of the hurricane. What we want to do is reverse that. We want to do a reverse four-push. Now, as far as earthquakes, we're not at the point where we can control the earthquake. But if you think of the Earth, not only is the Earth moving and the solar system moving, but the Earth's crust is moving. And as we saw last week, it's moving in places like Mexico and the Rim of Fire. Now, it turns out that since an earthquake releases the equivalent of thousands of tons of TNT, and if you remember when the North Koreans detonated their H-bomb, it had an earthquake of 6.3 on the Richter scale. The Fukushima earthquake was magnitude 9 The Haiti earthquake was magnitude 7. Now, the difference in energy release between a 7 and a magnitude 9 is 1,000. So that the Fukushima earthquake was 1,000 times more powerful than, say, like the Mexico earthquake was last week. Now, because of that amount of energy being released, before the earthquake occurs, there are precursors like temperature differences, radon emissions from the fault area that can be detected by satellite. And this is what our colleague Sergei Pulinets suggested back after Fukushima, that if you have a series of satellites that are looking at the Earth for these precursors, you can forecast when an earthquake is going to occur. Now, again, it wouldn't be 100%, but if you give people a warning of a few days instead of a few minutes, then you could save that many more lives. And eventually, once we master the full range of power of something like the sun, I'm sure controlling earthquakes would be a piece of cake. But since the sun, which is 4.5 billion years old, is not going to be around forever, eventually it's going to run out of its hydrogen fuel and burn up or fuse its helium. The sun is going to burn out someday. So we want to be in a position that we could use the principles of the sun to figure out how we're going to find a new home or create a new home in the galaxy or even beyond the galaxy. So the power of these forces, trillions of times the power of the biggest H-bomb we've ever detonated, gives you the scale of the power we're dealing with, not only from the sun, but the effects of the sun and the galaxy on systems on the Earth, like hurricanes and earthquakes. And the better we understand those principles, the better we can control them. And the better we can control them, the more power we will have as a species here on Earth and in the solar system. So I'll stop there and see if you have any questions.
Joel. Yeah.
Yes.
I still don't, the flare that's coming out from the sun is negative ions, positive ions, mostly?
Both.
It's both.
What you have in the sun is you have free electrons, and you have ions, hydrogen, which are protons in helium nuclei, which are protons and neutrons. So the magnetic field, which is spinning around the surface, will trap these particles in the magnetic field. And like I said, if you think of a rubber band that's stretched to the limit, right, and it snaps. So you break the field line, and then you eject whatever particles were trapped in that field. And that's what's ejected into the solar wind.
So, okay. So in mid-August, there was significant solar flare activity. But I thought, I mean, Ben Denniston stepped forward talking about that as strengthening Irma.
Right.
So we don't, at this point, see it as a big factor in the strength of Harvey, or no, or are we still looking at that?
We're still looking at that, but as far as I know, it wasn't.
Right, I asked Ben about that myself, and Ben said no.
As far as Harvey is concerned.
Yeah, right.
But the idea of our somehow generating man-made an ion transmission up into the ionosphere from planet Earth, that will somehow, it'll be like neutralizing it or something, or
Well, it's not really. You see, the ionosphere is about 30 kilometers up, so it's much higher than anything related with the hurricanes.
yeah.
Stratosphere.
What we're talking about is the troposphere between about 10 miles up, 10 and 20 miles up. Now, what's thought to happen with this Forbush effect, again named after the guy who discovered it, Forbush, is that if you have a geomagnetic storm hit the Earth's atmosphere, that storm will reduce the amount of cosmic radiation coming into the atmosphere. And if you reduce the cosmic radiation coming in, you reduce the amount of clouds that you form at the upper atmosphere. And if you reduce that formation of clouds, then the upper atmosphere will get colder. And that colder upper atmosphere, combined with the warm ocean or warm Gulf waters, that increase in the differential increases the strength of the hurricane. So if we could induce that the upper atmosphere, let's say 10 miles up, an increase in ionization, then you will heat up that part of the atmosphere instead of cooling it, and reduce the temperature difference between the upper atmosphere and the ocean surface. And that reduction in the difference will reduce the power of that hurricane.
Could you repeat that?
So think of the whole Earth, because what's left out of all these climate models is they figure out the temperature and the temperature of the water, but they don't explain how clouds form. How do you get the water vapor out of the air and into these little seeds of ions that form the basis of cloud formation? Well, it turns out, and this goes back to Henry Svensbark's work, is that the Earth is bombarded constantly by high energy protons, not just coming from the sun, but coming from the galaxy, from supernovas, from all sorts of things going on. And when we don't understand that completely, but you can measure the cosmic ray flux per square meter coming onto the Earth. If you have an increase in this cosmic ray flux, then you have an increase in ions at the lower atmosphere where you can begin to form clouds. If the sun, acting as our shield, increases its output of the solar wind, the solar wind acts like an umbrella to protect the Earth beyond the magnetic sphere of the Earth, but acts like an umbrella to protect the Earth from incoming cosmic rays. Now, if you reduce the amount of cosmic rays hitting the Earth's atmosphere, then you will have less cloud cover, and less cloud cover leads to a warmer planet. And going back over the record, soil records, glacial records, it's seen that you can measure what the cosmic ray flux was millions of years ago. And it's shown that if the cosmic ray flux was low, the Earth was cooler. And at times it was so cool that you had ice for almost to the equator. It was called snowball Earth period.
Right.
But if the cosmic ray flux is reduced, then you have what's called hothouse Earth. Whereas, as Ben showed last week, you have periods where there's no ice in Antarctica or any ice in the Arctic Sea. And it turns out that throughout most of Earth's recent period, like going back over the last 500 years, million years, periods of no ice are much longer than periods of where you have ice caps. So this idea of climate being controlled by CO2 is about as believable as you've all heard of the butterfly theory.
No.
Where it's thought that a butterfly flapping its wings in the Amazon
Yeah.
causes a disturbance that causes a storm, that causes a hurricane.
Oh.
You know?
Yeah.
Well, that comes from the same computer modeling as the climate models.
Yeah.
Because in the early 60s, this guy figured out that if you have a computer program with a small error, and you keep feeding back that error, doing it millions of times, you will get a bigger error. Now that's all in the computer. And a lot of these climate models are based on assumptions plugged into computer models.
Sure.
But if you look at the physical universe, what controls the climate is the sun in correlation with the galaxy. And this is what's completely left out of all of the climate models.
Which is why you have corresponding enormous climatic changes on the other planets where there isn't any man-made CO2. You know? Right?
Well, I heard there were a bunch of SUVs in Jupiter. So. The big red spot is a hurricane that's been going on for like 600 years or so.
600 years?
Yeah.
Yeah. Hey, Joel,
Yes.
how do they know that there were periods when there was no ice? How do they measure that? Or how do they know that?
Well, what they do is they go through the sediment core. And as you go, you might know that Kansas, back 100 million years ago, was an ocean. The middle of the America was water. And this is where they find dinosaur bones and everything. But if you were to, so what happens is you have an ocean, then as the animals die off, you get the sediment. And as the sediment goes up, you get this sedimentary rock. And the layers, the deeper you go, the back in time you go. Now, as you go deeper into the sediment, you can measure the isotopic ratios of various elements, like oxygen. Oxygen has a mass of 16, but there's an isotope of oxygen that is heavier. It's oxygen 18. It has 2 extra neutrons. Now, as water is evaporated from the oceans, the heavier isotopes stay behind. So as those isotopes are incorporated into living organisms, into rocks, you can measure in different layers the ratio of oxygen 16 to 18. And you could use that ratio as a proxy for what the temperature was back millions of years. And it's those type of ratios that give you an indication of what the overall temperature was planet-wide. And you can tell whether we had a temperature that would lead to ice formation, ice ages, or whether it was a hothouse period.
Journey to the center of the earth. So, I'm sorry, an ion is just a positively or negatively charged particle, or
An ion would be considered mostly positive.
positive charged
Right.
particle? Okay.
The electrons are always negative.
Oh, it's negative, sure, I know. Proton is positive. Okay, so an ion is just a positive charged particle.
And they actually used ions to measure the temperature of the coronosphere. As a matter of fact, I think it was 150 years ago, there was another solar eclipse, and what they do is they look at the corona with a prism that breaks the light into its various wavelengths. And looking at the corona sphere and looking at the spectral pattern of the elements that you see, you can tell what the temperature of that coronosphere is. And what this one guy did is he looked at the corona during an eclipse and he saw a new spectral pattern. And he actually named it a new element, coronium. It turns out that that coronium was actually iron that was stripped of 7 of its electrons. Now, iron has 26 protons. So in the regular state, it has 26 protons and 26 electrons. The hotter you get, the more electrons are ripped off. Now, if you have an iron atom and you heat it to, say, 10,000 degrees, you'll lose 1 electron, say. Now, if you lose 1 electron out of the 26, you still have 25 electrons. But because you have an extra positive proton, that becomes the charged ion. So you can measure the temperature by looking at the spectral pattern and figuring out how many electrons have been stripped. And you can tell whether it was 1,000,000 degrees or 2,000,000 degrees.
Wow. So you're saying that the coronium was really iron that was stripped of how many?
Well, see, here's the thing, is that iron is less than 1 part per million of the coronosphere. So most of what he was looking at were lines of hydrogen, helium, and a little bit of iron. So it's a very small amount of iron in the sun and a very small amount in the sun's coronosphere. But there is enough there that you can use that as a temperature gauge for the whole coronosphere.
Is it, why don't we just call a proton an ion?
Can you speak a little louder?
Is a proton and an ion the same thing?
Well, if you think of a hydrogen atom is 1 proton and 1 electron.
Mm-hmm.
If you strip that electron off, either by heating it
Or whatever reason.
or whatever, you end up with a single proton. That's an ion.
It's now an ion. Okay.
The same thing happens with like iron, like I was saying. Iron has 26 protons and 20 or 30 neutrons, depending on the isotope.
Mm-hmm.
So the word ion means any nucleus that has been stripped of its electron.
So it has a positive charge.
So it has a net positive charge.
1 or more electron, right? Doesn't have to be,
Right,
yeah.
but hydrogen only has 1.
Yeah. So it's going to be an ion no matter what element it is, as long as it has a positive charge. If some of those electrons have been stripped from its shell.
Right.
Interesting. Okay.
Right. And the cosmic rays coming in are considered mostly 90% protons, because they're the result of supernovas where they explode and the hydrogen, the helium is thrown out and it accelerated by magnetic fields and it invades the Earth constantly.
So what's the difference? Okay, so what do we get from the sun versus what do we get from the galactic radiation?
Well, the solar wind, for example, it would be in the range of energy levels of a million electron volts. That's a unit of energy at the micron level. Cosmic rays are 1,000 times more powerful than just solar rays, solar radiation. I'm not talking about the light, but the actual protons. So cosmic rays can have energy levels 1,000 to 1,000,000 times more than just the equivalent proton or helium atom coming from the sun. So cosmic rays are more energetic.
So you said that the sun, the solar winds provide an umbrella protective cover against.
Speak up, Betty, so we can all hear.
I said, so you previously stated that the solar winds provide protection for the Earth from cosmic ray radiation.
Correct, and that varies according to if you have solar flares, you have more protons, more ions coming from the sun, and they provide, and it's not just going towards the Earth, it's going across the solar system. So those ions coming from the sun will tend to block the cosmic rays coming in. They're still coming in, but the flux is reduced. So the sun, you can think of it as a thermometer for the flux of cosmic rays coming in. And these ionization experiments where we set up wires and we ionize the lower atmosphere, that is the equivalent of increasing the cosmic ray flux. Because instead of ionizing the atmosphere with cosmic rays, you're doing it with electrical energy at the ground level. And if you increase the ionization in the lower atmosphere, you provide the nucleus for the water vapor to condense on these ions. So we're actually simulating the galactic cosmic rays by using these ionization systems.
In that they create cloud formation.
Right.
And that cools down. Okay.
Right. If you have clouds, just think of it. During Harvey, is Harvey still up there? No. But you think of it, in the middle of Harvey, we had days of 70 degrees, 74 degrees.
Right.
We didn't even hit 80 some days.
Right.
Wow. Yeah.
It's because we had the cloud cover and the rain. Now, once Harvey dissipated and we reduced the cloud cover, we had the solar rays coming in. And it weren't being blocked. Clouds not only provide rain, but a lot of this sun's energy is reflected back by the cloud cover. And this is another thing that is not represented in these climate models, the effect of cloud cover on incoming solar radiation. So if you think of a cloudy day, just the other day, I was walking in and the sky opened up. And it went from 91 degrees to 75 degrees. degrees
Wow.
in a matter of 5 minutes.
Yeah.
So you just think of more cloud cover, you reduce the temperature. Now, where do the clouds come from? You see, it's not just the sun evaporates a huge amount of water every day from the oceans. But that water vapor has to condense on some kind of nucleus. See, water is a dipole. I was going to say bipolar. But if you think of it, H, the two H's and the O, so it's like Mickey Mouse ears. The H are mostly positive and the O is negative, so that water is attracted to magnetic and electrical fields. So if you have an ion, the water vapor will glob onto that ion. And the more water molecules attach themselves to those ions, you get the water droplets. And if you get enough water droplets and they reach a critical point, then they become heavier than air and then you get rain.
And in between, they become clouds.
Right.
It's called hydrogen bonding.
Well, you also have the oxygen in there.
Right, yeah.
So it's much more complex. You see, you hear the explanations of these climates, so-called climate, like Stevie Wonder. He says, well, the ocean is going to get hotter. And the atmosphere is hotter. And hotter air absorbs more water vapor. Now, the other thing they leave out is that water vapor is the most powerful greenhouse gas. 95% of there is a greenhouse effect. And 95% of that is due to water vapor. Carbon dioxide is insignificant as far as the greenhouse effect.
When there's an earthquake, right, or volcano eruption, like Krakatoa.
Hey, sorry, I'm sitting here because I have got some phone.
Oh, okay. Well, I'm just trying to remember the history of Krakatoa, right? You had this huge, explosion, right? And then there was and after that, you had a huge tsunami, just completely covered the island. So what's the process?
Well, also it spewed out. You want to talk about pollution? One volcano can pollute the whole atmosphere.
Yeah.
We ought to plug those things up.
Yeah.
But if you remember Mount Pinatubo in the Philippines in '91, I think it was, it blew its top, and it was much smaller than Krakatoa. But it spewed out, and it spews out carbon dioxide, sulfur dioxide, all sorts of chemicals. And some of those chemicals reflect the sun's rays back into space. So the year after Pinatubo was cooler. And the same with Krakatoa and these other great volcanoes. There was one in 1815 that was so powerful that the next year, 1860, was known as the year without summer. Because it spread the cover all over the Earth, especially the northern hemisphere. Now, the heating of the Earth's core is something we still don't completely understand. But the reason why we have these plates moving is because the magma is still hot. And the crust, which is lighter than the magma, is floating on magma. And there are certain holes in that crust, like Hawaii, and that's where the magma comes through when you have your volcano. Now, some of those are slow moving lava. Others they have a cap on them and they reach a break point and it explodes. And that's when you have one of these large eruptions. So the volcanoes and the earthquakes are related. That's why, if you remember some of the videos we did on the Pacific Rim of Fire, you have these volcanoes in Indonesia and Japan, and that rim is where a lot of the crust is going under another plate. And that's where you have the most earthquake activity and the most volcanic activity.
Is in the Far East.
Is in the Pacific Rim, but that Far East includes Mexico. See, Mexico,
And Alaska.
Washington State, California, Oregon, Chile. The biggest earthquake ever measured was in Chile, I think 1960. And it 9.5 on the Richter scale.
So confusing.
Well, people may have more questions, but I just wanted to mention that out in front there are three things that everybody should take. One is called "The Choice Is Yours." The other is a letter from the Foreign Minister of Yemen to the Schiller Institute, thanking us for the work we've done. And the third one is a letter from our Schiller Institute in Italy to President Trump. It's an open letter calling for him to defend Columbus and Columbus Day against the attacks, and making clear that the attack on Columbus is an attack on the Italian Renaissance. And it's coming from the same people who hate the Renaissance because of what it created here as well as elsewhere. So those three are out in front. Everybody can make sure you get one or more. You can take extras to get around.
Oh, sorry, what was the third thing?
Letter from Italy to Trump to defend
No, the
Columbus.
first one is called "The Choice Is Yours."
What's that?
The choice is ours. It was the lead of the briefing yesterday about the two directions that Trump's speech took, and what we have to do to determine which way it goes.
There's actually a move to try to get rid of Columbus Day. But it's been banned, or have they changed it?
Well, Los Angeles changed it to
Indigenous Peoples Day. Can you imagine?
And even de Blasio, who was Italian,
Yeah.
supposedly, in New York, has said he wanted to bring down the Columbus statue. Columbus.
Ridiculous.
Well, apparently somebody called me about some political meeting. He said that their Lee High School, Robert E. Lee, is now called Wisdom High School. Has anybody heard about it? Right here in Houston.
Yeah.
Yeah.
Jefferson Davis High School.
They spent a couple million to change the names of several schools. I think there was about 12 schools altogether, including one I attended, a middle school that was named after Confederate General Albert Sidney Johnston, which most of the kids then and now
Don't even know.
couldn't identify.
Why do you care to change the name?
Yeah.
It's so much of them.
Well, instead of changing all these names, I think they should tear out all these sports stadiums.
Yeah.
Because in Katy, they have a high school football stadium that they just finished.
Wow.
Cost $58 million.
Wow.
See the hypocrisy.
And that's so that these kids can get the TCI.
So they can get brain damage
Yeah.
before they get if the drugs haven't got nothing.
Yeah, so they can't think at all.
Yeah.
That's the goal.
And they get girls in it.
For entertainment.
Yeah, all for entertainment, right.
Yeah. Bread and circuses.
Joel, I wanted to just point out that, maybe you have something to say about it, but it's a well-known phenomenon that a precursor, you could say, to earthquake activity is that animals like pigs, suddenly herds of pigs, move rapidly out of the area. You want to say anything about that?
Well, they have something. I don't think cats react that way.
I think they
But
do.
yeah, well, animals have they can sense different parts of the electromagnetic spectrum, and it's thought that they sense that there's a change in the electric field of the atmosphere, or they sense. See, what comes up through the cracks is also radon. Maybe they have some sense of radon, which is a decay product of uranium.
Infrasound.
And the other, I mean, and animals are known to have a lot of different sensory capability. I mean, a lot of, animals will know when a storm is coming, long before you hear any lightning, thunder, anything like that.
Birds can detect the pressure differentials.
Dogs will hide under the bed.
Right.
They could do that, but they still can't build a rocket.
Yep, that's true, absolutely all right, Joe, yeah.
Now, do I hear a bid for a piece of the moon?
So, so water is so today when we have these storms like Harvey, is the ability for these things to hold more water, is it just the same as it always was, that it's holding the same amount of water, or is it more intense, or because of so much cement and concrete that the water is just not having a place to go, and so those trillions of things that get dumped just don't have anywhere to go? Or is it a combination of all that?
Well, that's part of it. It's a combination, but mostly it's because we haven't built a real reservoir outside of the Conroe Lake and Lake Livingston outside.
But we didn't have one, like we haven't had reservoirs in the past 30 years,
70 years.
Or 70, so I've never had, 8 inches of water in my place before. So I'm wondering, where's this water coming from? Where before it would rain and I would go, oh, how lovely, I'm gonna make a cup of hot chocolate and sit by the window and enjoy it. That was the old days. I loved thunderstorms because it was the time to have hot chocolate and marshmallows.
But there is.
But now it's carry everything up the staircase. And I want to know why. Why can't I have my marshmallows and enjoy it?
You just have to have them.
Well, if you think of it, when we built those reservoirs, Houston had a population of 400,000.
That's right.
And now we have over 4 million in the area.
And a lot of those are in floodplains.
If you think of all the malls, all the highways.
So the malls and highways are keeping the water from having a place to go? Is that the bottom line? Or
Well, it's not soaking into the ground like it was before.
It's creating a place for it to go, which is where you don't want it to go.
It's going into the yeah, because water's going to take the least of path of resistance.
Mm-hmm. Right.
So if the resistance is hindering it, I guess, okay, I'm kind of understanding.
I mean, Jackie, did you hear that Arthur Story interview, the former head of the?
Yes, I did last week.
Yeah.
Right. Yeah.
Right, where he said we knew this was going to happen.
So I wonder, how did he know? Because he knew of all the
buildings. If you had a
buildings.
slow-moving storm,
Uh-huh.
it was partly because it just moved very, very slowly. It had a large amount of rain in it, and it was moving so slowly. It's the same thing that happened with Allison, only even more so with a stronger storm.
Mm-hmm.
So the amount of rain came a lot from just the fact that it was heavy rain, but also was, there. I mean, Irma just went up Florida, dumped rain. Harvey didn't do that, and that's the kind of thing they knew they should have planned for, and they just didn't do it.
So are you all going to make an effort to get in touch with, like different, like council, like who would be the first person for me to approach? Like a city council member, like Mike Laster, like Al Green, I'm wondering.
Your senators, your congressmen, because this has to be a federal.
Right, it has to be a federal thing, so everybody, okay. Now, the story person, I'm trying to remember, this gentleman who did, because I've driven past that many times. Mm-hmm. So now, did you say Arthur's Story, he's still alive in his
He's still alive in his own home flooded.
In his own home flooded. Now, is he gonna have a town, why can we invite him to have a town hall meeting, and where is he up to right now? Involved? Yeah, let's get Arthur's Story, what's his phone number?
That's the question.
Where does he live? Does he live
Briar Forest.
in Briar Forest?
That's what we understand.
Because I mean, if he has some kind of clout, why wouldn't, we want to get him?
Oh, we
on
would
board?
want to. We would want to.
So,
Yeah, but it's got to be a top down. You think of the TVA, like what Marcia went through last week. Is that you had these floods, you had these storms, droughts, and it wasn't until there was a top down decision saying we're going to control this whole valley that they were able to deal with that problem. The same thing in Houston and in Florida is you have to have a top down, because the Army Corps of Engineers can have all these plans like they had in New York City. But if they're told every year, well, there's no money for that, so just do it what you got.
well, we have to put pressure. If, people keep putting pressure on the Congress, because they're gonna get tired of hearing them rant, us ranting.
But what they need to hear is LaRouche's 4 laws. They need to hear, because it isn't just pressure to spend more money. How are you going to spend trillions of dollars? You're not talking billions, you're talking trillions. Well, where's that going to come from? And Brian sometime soon is going to go through a discussion on the credit system. But I mean, it's a different conception,
Right.
than a bank that we think of today with money.
Mm-hmm.
It's a Hamiltonian process, and that's what they have to hear from the constituents. But again, that's what these guys have to be pressuring President Trump. In other words, get a whole process here that the population is part of.
Right.
Understanding it's something higher level than simply the conception of money.
The sad thing is there's just such a smaller entity of people who are sophisticated enough to understand this Hamiltonian, these principles you all are talking about. That's the sad thing. I just feel like, we need we need more education, a lot more education of people.
Well, we have the examples. I mean, if you think, were people smarter than Houstonians in the Tennessee Valley, or
Right.
these hillbillies smarter than?
Right.
We have the example of the Three Gorges Dam. We have the example of what China's done.
So what was the level of corruption during that time period versus today?
Well, what happened was that the powers of the people who were doing the corruption collapsed because their system collapsed. That's what happened with Lincoln.
So
We'd still have slavery today if it weren't for the fact that the British and their Confederate friends decided they were going to pull out of that Congress. So that allowed the people who had some idea of what the United States should be to impose that policy. But they did it to themselves because their system collapsed.
So
We have to wait till their system
We don't have to
collapses?
wait till their
Oh, no.
system collapses, but we have to create conditions so that as it collapses,
what kind of
we
suffering
can
was
change.
going on when that system collapsed? Like, what was going on physically on the ground? What did that look like back then?
Well, you heard about the Great Depression.
The
I
Depression,
mean,
so standing
you
in
know,
soup lines, waiting,
right,
there's
it was-
a lot of people.
But the point was that the Morgans and the Mellons, they didn't have the power to control things.
And you had
that they
leadership.
previously.
You had a role. Because look, the Depression happened under Hoover.
Yeah.
And Hoover said the recovery is around the corner, and a chicken in every
Pot.
pot.
Is that what he said?
Yes.
And in Europe, they had the same depression.
It's just around the corner.
It's around the corner. Everybody will have a chicken in their pot to have a soup or whatever.
So you can't wait for the because Europe, they had a similar depression, and they ended up with Mussolini and Hitler.
Huh.
So it has to have a core leadership that knows what to do.
And we were saying earlier that Trump's speech at the United Nations kind of gives you a sense that there's two factions, two systems clashing in this administration, because part of what he said was really good about the sovereignty of nation states. We don't want to impose our way of life on other nations. So in other words, he's making clear we're rejecting the Obama policy of regime change wars. And then he says basically the opposite about North Korea, Iran, Venezuela, Syria.
So you're saying he's contradicting himself?
Well, yeah.
And
that's
is
what
he
I-
doing that, do you think, because he's just ignorant? Or is he doing
No.
it because he feels pressure from the evildoers to say that to make them happy? Do you think he's doing it to just keep himself alive?
Well, he's certainly under major threat. He's, there's a coup. I mean, it's Robert Mueller. We will have a dossier, hopefully before the weekend is out, which we'll let you know, and it'll be on the website, and we're going to publish it, which is on Robert Mueller. But more than that, what is this structure of the FBI, NSA, CIA that, has been, exposed in spying on this president, on a campaign manager, Manafort, and it's the same crowd that covered up for the Saudi role in 9/11 and went after Lyndon LaRouche when LaRouche was a presidential candidate. Exactly the same, Robert Mueller, to name one. So
that's when they started, when Lyndon LaRouche got the most pressure against him, and the mail fraud thing that came about is when he was running for president.
No, when Reagan adopted the strategic defense
So that,
initiative
you asked about that.
in
Somebody asked
'83.
me about that. Is what happened with LaRouche like that, and that makes sense. That's the answer I gave somebody. He's like, he was probably challenging the power structure in a major way that would make them clamp down.
He was able to shape a president.
Yeah.
And now Reagan had a lot of problems. Remember, George Bush was his vice president. Probably one of the reasons why he got shot.
He only got assassinated in the first 90 days.
yeah.
So he had all sorts of traitors in his administration, but he listened to LaRouche on that critical issue.
Yeah.
And we have to have the same effect on Trump, because Trump wants to do good, but he's confused on a lot of these.
He's surrounded by people who are
And
evil.
I watched the Benny movie last night,
A Good American.
and Bill Benny. And the one thing that really shocked me was he was in his mid-20s in '68. And he said he had been recruited to do Army intelligence. And then he was so good at figuring out these patterns that he was recruited into the National Security Agency. And he said that in late 67, 68, he and his group were warning the generals that there was something coming in Vietnam, and they ignored it.
Right.
Just like they ignored the signals of 9/11. And if you hear I could have sworn that General Westmoreland sounded exactly like Michael Hayden.
Yeah, because he lied and said, "Oh, we're winning the war in Vietnam."
Yeah, just 200,000 more troops.
Yeah.
But if you think of what's necessary, what Benny said at our conference is true. What Trump should do is go into all of these agencies, national security, the Pentagon, and start firing the top generals down to the lieutenant level. And you could probably have a janitor that'll do better than a lot of these generals, because they're not trained in anything like Petraeus. These generals, they used to be trained at West Point to be civil engineers. Now they're trained as Princeton, Harvard, government.
Geopolitical ideals.
Yeah, and Petraeus's doctoral thesis was on learning the lessons of Vietnam.
Oh, great.
And obviously they haven't learned anything.
Right.
When Chuck Schumer said they have whatever 50 ways to
6 ways from Sunday.
6 ways to Sunday to do to. I mean, that to me is such a horrifying comment for a political figure, a senator to make. It really it sounds so much like what a gangster of the Al Capone period would say. I just can't understand how he could be so stupid as to make a
public
statement like that
on TV.
On TV.
Well, it's true. What he said is true, because national security agencies have been covering up 9/11, Kennedy assassination.
28 pages.
Martin
But
Luther
he's
King.
putting himself now in that category.
Well, what
to-
about the interviewer, Rachel
Right.
Maddow?
And for her to sit quiet, I mean,
Right.
she should say, wait, are you related to
Could
any
you repeat that?
Al Capone?
No, what did she do? She said, we'll take a station break.
Yeah, I can't believe
Well, that's
the
the
lack
truth.
of
That's the lack of journalism.
indignity. I mean, you should be indignant at a comment like that. I mean, what are you saying? That this is a country of gangsters now? Is that what you're telling me?
Yeah.
That's awful.
Mass killer. If you go against their system, they're gonna kill you.
They're gonna kill you. You have 6 ways to Sunday. Yeah.
But the other thing is, if you don't go against the system, you're gonna end up in a thermonuclear war. So
Yeah, right. That's right.
Pick the way you want to destroy yourself.
All right.
okay, last chance.
Thank you, Joel.
Thank you.
So,